All right, so part two on your notes here, and we've got to go through that the same process. We're going to look for what values of A make this inequality make it true. Which A values are solutions. And now, fortunately for us, it's already been factored out. So let's again use this is just a tool to help us, but um, let's graph it. And this graph is not the answer itself, it's just a tool. So we're kind of pretending for a little bit that it's a minus 2 times the quantity a minus 5 squared. That all divided by a minus 4. We're saying that that is less than or equal to y here. And not that it is in actuality, just using this as a tool. Once again, because it's been a big point of confusion, this graph isn't the answer. The graph is just a tool to help us get to our answers. So that all being said, we've got a few things that we want to start off with. And first, let's graph our roots. We've got a root at positive 2, and that's from the a minus 2. So we have a root of 2. We have a double root at 5. A double root out here at 5 because it's squared, so there's 2 5s. We also have an asymptote here at 4, and so let's go ahead and work with that one. Nothing at 4, and an asymptote. We can't have an a value that's 4 because if we plugged in 4, even though we'd have a number up in the numerator, and you could still have a 0, that would be fine. But we can't have a 0 in the denominator. And if I plugged in 4 right here, I'd get 4 minus 4, and it would give me 0 in the denominator. And again, that's we can't have that. And so here we go. In this case, it would be undefined when you divide by 0. Sometimes if it's 0 divided by 0, it's technically indeterminate, but that's really not that important right now. So nothing can be on my graph here at a equals 4. But the rest of it we can still graph. We've got looking through, and my numerator, I can kind of think of this as essentially as it's a cubic up top divided by just a single term or a single a here. So we're going to end up with what's an even function. And so my end behavior, they need to be going the same way. Now, as I go on through, I can look at it and say, hey, my value out front, it will be positive. And so that's going to start at positive infinity, and it's going to end at positive infinity. Now, as we're going, I've got to go through my root here, and I'm going to be heading closer and closer, and my graph's not super accurate. You can hit this into your calculator to get it a bit more accurate. But I'm getting closer and closer to this line, but it's an asymptote. I'm never going to actually touch it. Never going to actually touch it. And a few ways to think about why we're going to be heading more and more and more negative as we get closer and closer to it. If we plug in a number like 3.9, something really close to that, let's run through that for a second. If I plug in 3.9, I'll get something right around 2 up on top here. So 3.9, that's close to 4. Or maybe I shouldn't do close. So let's do exact numbers. So if I plug in 3.9, I have 1.9 times, well, 3.9 minus 5, that's going to be negative, let's see, negative 1.1. That's going to be squared, though, and so let's see, that's going to be positive 1.21 after we multiply it out. So a positive times essentially a positive divided by, if I plug in 3.9 right here, I'm going to have negative 0.1. And so now positive on top divided by a negative in the bottom gives me negative, and the closer and closer and closer we get to 4, but approaching it from the negative side, the closer and closer and closer we get to 4, it's going to get, we're dividing by smaller and smaller and smaller pieces. It's going to be, the value of it's going to be getting incredibly high, so it's going to head towards infinity, but it's a negative, so it's going to head towards negative infinity. Okay, let's think of now some numbers on the other side of our asymptote, because again, we can't actually plug in 4. It gives us undefined right at that location, at that a value. But if we plug in numbers that are just slightly bigger than 4, now we'll go through that same process. So something slightly bigger than 4, minus 2, so 2.1. I'm kind of think of it as plugging in 4.1 for a. Yeah, it gives us 2.1 times, well, 4.1 minus 5, that's going to be negative 0.9. But that's squared, so that's going to be a positive 0.81. So a positive times a positive here, divided by, well, this time 4.1 minus 4, that's going to be 0.1, and it's positive. Now, a positive on top and a positive on the bottom gives us a positive. And so now we're on the other side of that asymptote, and we're heading towards positive infinity the closer and closer we get to 4 coming from the positive side. Now, the closer and closer and closer we get to 4, the smaller and smaller and smaller pieces we cut it up into, and it gets closer and closer and closer to positive infinity. So it's coming in from the other side of the asymptote. And we'll come back and talk about that in just a second here. Now it's going to come on down. Remember, so big transition away from the asymptote right now. We're heading towards, so this was a value of 2, kind of 2, 0. Here we have the asymptote at 4, 0, and actually anywhere on 4, we can't plug that in. And now we're heading to a double root, so back to our roots at 5, 0. What happens at double roots? It bounces. And so it's going to come on down, hit right here at 5, and then head on back up, heading towards positive infinity. Okay, so here's our graph, and that's roughly what it looks like, heading towards positive infinity here, heading towards negative infinity on the left side of, or on the negative side of 4. And we're going to do the same thing we did on the previous problem, and we're going to look for where it's less than, or a rational expression this time. It's not a polynomial expression anymore, where it's less than 0, or in other words, just where it's negative. Here's our first breakdown, where a is less than 2. This is going to be a positive, and we don't want positives for our solution. My output here is positive, so that's not part of my solution set. Next, I have where it is from 2 to 4. Here I've got negative output, so negative, and those are the ones I want. Remember, this time it asked for or equal to, so we're going to have to be kind of careful about that. We'll talk about that in just a little bit. Past 4, between 4 and 5, and really, since it's a double root, it's positive in all these except for right at 5. So we've got positive and positive, but right here exactly at 5, we are at 0. It's not negative or positive. All right, so once again, this whole graph is just a tool to answer this inequality right here. And so let's start to break that apart. Our solution set, so solution, we're looking for where a makes this rational expression either less than or equal to 0. So it's either negative or is equal to 0. And so let's take a look at that. As we go across our graph, it first starts to become equal to 0 right at 2. So 2 is part of my solution set. So I've got 2 is less than or equal to a, because as I go past 2, now I'm in parts that give me negative, and this is what I want. So 2 is less than or equal to a, which is less than 4, because once we get to 4, it's no longer negative, and it's not 0 either. So right at 4, that's why there's no or equal to, because 4 is our asymptote. We can't plug 4 in. So that's the first part. And then, or a is equal to, where else could we get a solution? Right at 5. If we plugged in 5, that is also one of our solution set because it's or equal to. So here's our answer. Now I want to talk really quickly here at the end about the asymptote. If I were to think of the quantity a minus 4 here, that's to the first power, and the first power is odd. Just like on our odd degree polynomial functions going opposite directions, their end behavior going opposite ways, it'll be true for asymptotes. That if it is an asymptote that is to the single power, so just one asymptote of 4, then they're going to go opposite ways on that asymptote. And you can reason through fairly quickly about if it's going to be heading negative or heading positive by plugging in some numbers very close to that asymptote itself, like how we did with 3.9 and 4.1. You can reason through and see, well, hey, will this be negative or will this be positive? If it were squared, then this, and just talking about the asymptote itself, nothing else here. If it was squared, that's to the second power, that's even. In those cases, it would head the same direction. So if we had an asymptote at 4, and I'm ignoring the rest of the function right now, but here's our asymptote at 4. If it was a something blah 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 over a minus 4 squared, then at that point that's going to go the same direction. They're both going to head positively, so it's going to head up to positive infinity on the negative side and head up to positive infinity on the positive side. It will never actually exist right at 4. That's still our asymptote. But we'll have it heading towards positive infinity on the left side and towards positive infinity on the right side. All right, so again, odd power asymptotes will go opposite directions, and for even ones, they'll go the same direction. All right, hope that helped.